Hello, everyone. Oh, thank you. So my name is Reza Rokni, and I'm a developer advocate at Google. I'm working for the Dataflow runner. In this talk, we're going to cover an advanced use case of timers in the state API to solve time series problems. In the first part, I'm going to go through a more procedural way of solving it using the state and timer API today. In the second part of the talk, Tyler is going to cover a more declarative way that is coming in the future around Validity Windows, and I'll let him cover that in more detail. So let's just think about some of the issues around dealing with time series. So this is the Wikipedia entry for time series. In my mind, time series is a series of data points that are ordered by time, and sequence is important. So there's a couple of things there that make you go, when we're doing with Beam. One, order and sequence are important. So these can get tricky when we're dealing with a Beam pipeline. The next piece is around the way that generally people process time series. So with time series, we will tend to build interval windows and do some aggregation on that time series. Quite a lot of the use cases, a few I've worked in FSI, for example, we also want a value when nothing has been seen in that window. In other words, you want to process when there's no data going into the pipeline. And Beam is awesome at processing data, but what do we do when we've got no data to process? So I'm going to tackle that first part. And to illustrate it, on this table, on the x-axis, we have some time series as columns. So time series 1 to time series 5. These are all time series. We can think of them as TS1 to 5 as keys. On the y-axis, we have the interval windows, so T0 to T1, T1 to T2, etc. For the circles, this is an indication that within that time interval, that time series had some data. Where there's a square, there was no data for that time series. So if we look at time series 1, the first column, we can see that in that one, in every interval window, there was data to process. So we're always going to get an output for every interval window. As we move on, however, in time series 2, there's a gap. There's a point where there was no data seen for that particular time interval. And things get a little bit worse as we move down through T4, T5. What we'd like to do is fill those gaps. I'll come in the latter part of the talk on how, what values we do fill them with. But for the first part, we want to be able to process something even though Beam has not seen anything within that time interval. So there are several ways that I've explored, and as you all know, Beam is a very versatile toolkit. These are the three ways I've done it. I'm sure if you spend time looking at it, you might find some other options. But the three options that I've explored, the first is using an external system to continually output data for every time interval that you're interested in. So for example, if you're doing aggregations every minute, then send a Noop object every minute into the pipeline. The second version is one where we get one of the utility classes in Beam to actually generate the data for us, so we don't have this external piece. And the final one, which is the one we're proposing as a nice solution for this, is something called looping timers. So let's go through option 1. So imagine you have an external system. One is actually sending our real data. That's the time series source. And this external system that's just monotonically sending a value into the pipeline. So here we could join these two things together. Once they're flattened, we now have dots in every time interval. Now, we had 5 time series. So one of the things we'd need to do if we're sending one dot in is actually do a fan out. We'd have to fan out that dot into 5 time series. What if there was 100,000 time series or 1,000,000 time series? Now we're going to have to take that dot and multiply it by 1,000,000. And we're going to have to start thinking about maybe doing hash buckets so that we don't cause a choke point within our pipeline, as this needs to move to all of the workers, the values. You could actually still do this in the external system, but then you're sending 1,000,000 points in for every time interval. The other problem is, what if the set of keys that we have keep changing? So there was 1,000 time series on Monday, there's 5,000 on Tuesday, and then we're back to 1,000 on Wednesday. And this is a very common scenario if you have, for example, IoT devices. You'll be adding IoT devices, removing IoT devices, so the keys are coming and going. Now, again, you could code this in, right? You could figure out a way for your external system to actually send this as a signal as things are being added and removed. It's possible. You could even get fancy and do something where you take the time series of actual data, do a distinct against that time series, which will give you the list of keys for that interval window, and then you join it back and use that to generate the fan out. This is all looking a little bit icky. That's the technical term. So what if, and one of the other problem, of course, with this is with an external system, we've now created the pipeline and something else that we need to build and monitor and maintain and all that kind of good stuff. Option 2 removes that problem of having something external to pipeline. We could use the generate sequence utility to actually generate for us these values. So now we're all contained within one pipeline. However, we still have all that distinct and dynamic list problems to solve. So the third solution is one we explored with Ken and folks around using a timer to actually solve the problem for us. So this is the formal definition in the Java docs of what a timer is. I have a slow and rather dim-witted brain, so I simplify things. For me, it's an alarm. Right? I set a timer, it fires off an alarm. Some point in the future, I get to do some more processing. Okay, how does this help us? So let's imagine we are creating interval windows of 1 second, and these are those interval window blocks. What we have in that first interval window, we have a piece of data arrive. When this piece of data arrives, I can now, using the timer API, set a timer. And I'll set the timer to go off in the next interval window. There's a sharp edge coming up in a moment that I'll describe, and that is with normal fixed windows, you can't do that, and we'll describe how you work around the limitation. But we set this timer, and we're going to set it off to go off into the next interval window. In the next interval window, there is no data. We haven't seen any data arrive from the outside world. However, we do have a timer, and because the onTimer event gets called, we now have an ability to generate a loop object. We can set the timer again, and then we can continue moving forward, looping through and continuously adding this timer to every time interval, therefore allowing us to fill these gaps. The sharp edge, so the timers are a key window, and fixed window is going to close. So we need to put the timer in a global window. So we need to flow our data points into a global window before we can use the set timer within the next interval window piece. So here is, so we put it into a global window, and on the timer, we then reset the timer. With this, and there is a detailed run through of this with code on the Apache Beam blogs, if you want to go try it out. There are some advantages over option 1 and 2. We don't need to do the fan-out operation, because every key becomes self-contained. It sets its own timer. It starts doing its work. We don't need to initialize the timer for all of the key space at the beginning, because when we first see a key, we know we have to set the timer. So if the list of keys dynamically changes, it doesn't matter anymore, because the timer will be set once the key is seen. The other bit of a sharp edge, you do need to think about a time to live for these timers. So if you imagine IoT devices, they come and go. You don't want to continually create zeros for an IoT device that hasn't existed for a year. You want it to actually stop. So the way you could do a time to live is actually using the state API, store the last time a real value was seen. And if you haven't seen anything for 24 hours that's new, then you don't set the timer anymore. So that's, and how long you set that and stuff is kind of arbitrary, but it's a business decision. So a little bit of a sharp edge. The other piece that this helps us with is the next part of dealing with time series problems. So in the first one, we have a reasonably nice way of actually generating data in all these time intervals. But quite often what people want to do is they want to take the data point that was last seen, hold and propagate that onto the next interval window. A concrete example of this that we'll run through is building Candlestick Charts. So for those, you've seen these trader applications. These Candlestick Charts, I believe, was a Japanese rice trader who invented them in the 1800s. And they actually are very nice because they encapsulate quite a lot of information in a very simple visual, right? They have the high and low prices seen within a time interval, and they also contain the opening and close values. Now, in simple stats, that just becomes min, max, and last and first values seen within the interval window. So, again, to help with this, let's have some actual data. On this table, there are 3 columns. The first column is a timestamp. The second column is the price that we've seen for a stock. There are gaps, and there are times when a single timestamp may have 2 values, one for stock A and one for stock B. You can see where there may be some places where once we turn this into interval windows, that we're going to have some gaps. So what would this look like if we did a fixed by duration 1 second window with a group by key? We're going to end up with something like this, where we have 4 interval windows. We're going to have an iterable list of the values seen within that window for each stock. And if you notice in interval 2 and interval 3, there are gaps for both of those stocks. Now, to build our candles, so one of the things that the institutions will often want to do when they build the candles, so the simplest way to do this is fix window and do first and last element in the window. That allows us to build this first candle with this data point. The next one, we can do the same thing. However, some institutions would say that the last value seen in the previous window, the last price seen in the previous window, should actually be the opening position on the current window. So the last price I saw should actually be the price that we opened with on the current window. In other words, they want the close from the previous value to become the open of the current one. And in the Beam world, that's the last value seen in the fixed window behind us to come into the fixed window that we're currently in. There's no data for the next one. We never saw any values coming from the outside world. How do we build that one? Well, we can, again, hold and propagate. So we've got the close value now becoming the open value of this new interval window. There's no data, so actually the open is also the close, right? Because the value is what's been propagated. And we continue. So this is all, this is the use case. And to solve it, we go to a stateful DoFund, but there are some sharp edges again. So stateful DoFunds allow you to store some state per key window. So does this on its own solve our problem? No. The problem being that when we do fixed windows, they're going to get garbage collected at the end of the window. When the window closes, the state disappears. So I have no way of taking that state from one window to the other. Just like in the timer case, however, we can use global windows. So imagine you do fixed windows against the values that are being processed. So we actually build up the first and last and everything within that fixed window first. We then take those accumulators and re-window them into the global window. Now, the global window maximum value is set to, well, it's not infinity, but it's a very large value that we're not going to hit. That's great. I can now take state, sharp edge, there's no order. The moment we re-window on global windows, there is absolutely no guarantee of the order that the accumulators are going to get processed in. And sequence is very important for time series. So how can we solve for this piece? So what we can do is, and by the way, it might be when you're testing and stuff, things look like they're in order. So like if you're doing a streaming pipeline and you're doing a global window, it may just happen that everything looks like it's coming out in order. It's entirely coincidence, right? There could be a glitch and it will come completely out of order. So that's just one thing to watch out for when you're doing testing. But here we have these fixed windows. So each one of these blocks is a fixed window, T0 to T3. We put them in a global window and we put them into bag state on the in the global window stateful function. If you notice, the bag state is also unordered, so there's no guarantees there. But we do have our on-timer alarm, which is being set on event time, not processing time. It's being set on event time. And that allows us, when that on-timer fires, we can actually read all of the values in our bag state, in memory sort them, and then daisy chain the close into the open, the close into the open, and get our values, and output the value to the on-timer's event time. So you may have some stuff in there that's beyond the on-time event time, but if you want to make sure everything's coming out at the watermark level, then you do it only to the on-timer event time. And this allows us to make sure that we've got nice sequential order on the things that are coming out. There are some more sharp points. So what we'll end up with is this, by the way, wrong, yeah, I should have got my slides the right way around. So essentially what we'll end up with after we're doing that processing, we have those lists, and then we have the previous close value now being made available to us within all of these interval windows. So for stock A, 1.53 price is now available in the interval window 1 to 1.99. The sharp edges. Limitation number 1, sort in memory. So we do have to read that list and sort it in memory. The mitigation for this is that we use the fixed windows beforehand, right? So rather than just sending a list of objects to the global window, we're sending a compaction of the data to the window. So in the case of time series, we've actually got quite big numbers of rows in without any problems, because once the aggregations happen, you got like 5 doubles or whatever that you're dealing with to do the processing. Limitation number 2, today the bag list, you can't remove an element on its own. You have to read the whole list, remove something, and then write the whole list back again. When we are going through and processing things on event time, we need to garbage collect as we go. And this is inefficient, right? So this is a chunk of processing that's happening every single time. There are mitigations. It's beyond the scope of this talk, but we're putting some pull requests and stuff in hopefully soon on some examples, which will show some of the ways that you can mitigate it. There's also a great chat on the dev list. I think Reuven started it around sorted map for state. So the moment that comes, I'll have a very happy day because I can delete like 80% of the code I've written to do the mitigation. So that would be really cool. Hurry up, Reuven. The final problem is late data. So everything is sequentially ordered, and we're doing our order buys on timestamp. If you get late data arriving, you're going to have to deal with that logic in some way, or not deal with it at all. Like in your branch further up, say if you got late data and you don't want to drop it, send it on a different branch. Mitigation for this, like the really clean one, I think is whenever Beam we decide to support like retractions. That would be an interesting way to solve this. And so with that, that's a way of solving that problem today. There are sharp edges. One of the other ways that you can solve this, so that was a very mechanical way of working through the problem, is actually a nice declarative way of solving the problem through Validity Windows. And for that, I'm going to hand over to.
Thank you, Reza. Hello, I'm Tyler, and I'm going to talk through this validity window thing. Reza, do you have it? Clicker's not working. Okay, that's fine. So validity windows are this theoretical approach that we came up with trying to figure out how to approach a specific type of temporal join. But it also happens to model this gap filling stuff pretty well, and it does it in a functional way using windowing rather than this more imperative kind of straightforward procedural way that Reza was talking about. It can only be partially implemented on Beam today by misusing certain windowing features, so I'll kind of describe that. And it's described in more detail in Chapter 9 of the Streaming Systems book, which I add there just in case you want to learn more, because we're only going to cover kind of the high-level points here. So the use case I'm going to talk about is currency conversion, which is, of course, really similar to stock pricing, basically the same kind of concept. But imagine we want to join two streams. We want to join a stream of currency conversion rates. So, for example, you know, one euro converts to 114 yen, that kind of thing, with a stream of currency conversion orders. So I've got 2 euros. I want to convert this to yen at a given point in time. And you know, doing so would then thus produce a value in the target currency of, say, 228 yen. So imagine, you know, this is roughly what our stream of currency conversion rates looks like. So we're getting, it lists the currency, what the rate is, and for each of them we have both an event time that's the official time at which that currency rate goes into effect. And we also have a processing time that is when the system learns about this currency conversion rate. And because the world is as it is, these things don't always arrive in order, so we'll see how that complicates things down the road. But if you take these currency conversion rates, each rate is effectively a single point in time, but if you kind of lay them out on a timeline, they effectively partition up time, right? They split it up into these sections where, starting, before we've seen any rates, we don't know what the currency conversion is. But as soon as we see that first rate of 114, we know everything from 12 on until we see another rate is 114. And then at 1203, of course, it changes to 116, and at 1206 or 1203, 1206 it changes to 119, and then 119 carries on until we see something else. So what if we want to join these price quotes with an order request, but the order requests aren't necessarily going to land, specifically at the same time as one of the rates? How do we know which price quote to join with? I mean, we can intuitively, looking at it laid out this way, see that, but how do we, declare this within our pipeline? Well, these sequence of quotes is effectively delineating a sequence of pricing windows, right? And this is what validity windows are. They're essentially windows that are defined by points in a timeline. But as I alluded to earlier, there is a complication here. Quotes may arrive out of order, so you can't just sort of assume, well, I've seen a currency rate quote, and then from now until the end of time, it's that rate until I get a new quote. To illustrate this a little more, imagine we look at our timeline here. So we start out without having seen any quotes, everything's undefined. I'm going to kind of stack here a succession of updates to this timeline as these currency conversion quotes come in the order, the processing time order we stated. So if you recall, in processing time order, the first one to show up was the 114. So okay, that's going to split time at 12 o'clock, and everything after 12 o'clock is going to be quoted as 114. That's fine. But the next one we got was 119, right? So that's going to split at 12:06 and go forward. And because we had then this late arriving 116, when that shows up, it actually goes back in time and splits things, right? So in order to actually give an accurate quote of what the price is at any given point on this timeline, you need to know if you've seen all of your input up to it. This is the whole watermark thing we talked about yesterday in the SQL talk. Fortunately, Beam has this thing called event time windowing in it that is intimately tied with watermarks and understanding event time progress. And you can actually implement validity windows in Beam today. It's pretty straightforward. If you've ever implemented a windowing function, it's basically two functions. It's assign windows, which gets an element, places it into an interval window, and returns it. So all we do is we assign it to an interval window that starts at the event time for the quote and extends all the way to the end of time. And then there's this merge windows call. And what that lets you do is as you get multiple windows for a key, it lets you look at them and say, okay, based off of what I'm doing as a window function, do I want to merge any of these together? So we use this for session windows, for example, where we'll place records into these small proto-session windows that start at the timestamp of the event and extend. Say you're doing a session window with a 5-minute timeout. We'll put them in these 5-minute long interval windows, and as they come in, if any of them overlap, we merge them together into a single session. Well, it turns out you can abuse this and go through here, and if we find any of these two interval windows that overlap, we take the earlier one and we chop it off at the timestamp of the later window. So we're basically shrinking it. And we do that by merging it into a new shrunk window. That's not what merge is intended for. As long as you're just playing with the windows, this works great. And this code does exist. You can play with it on GitHub. There's a unit test. It totally works. But it only works because we're only dealing with Windows. What's missing is, do I have a slide for this? No. I'll get to that in a second. What's missing is that while we can kind of make the windows do what we want, If you think about it, when you have a window, if a window is, say, 10 minutes long, and maybe it contains 20 different data points, if you want to go shrink it to 5 minutes long, semantically what you want is you only want to include the values in it that were in that first 5 minutes, right? The values that were in that later 5 minutes should go somewhere else. And we don't have that kind of functionality in Beam currently. Reza alluded to retractions. I think part of the retractions work is part of what's necessary to be able to support this, and then there'd be a little more work in addition to that. But anyway, with this implemented, if you wanted to visualize this, if you've ever seen the animations like this is the x-axis is event time, the y-axis that's kind of scrolling is processing time. But you can just see what this looks like. You get these quotes coming in, and if they come in as point rates at the top. We'll kind of wait till it cycles here. They come in as single points, and when we do the window, which is basically the window assignment, they get put into these infinitely long windows, and then we group them together, and then the grouping time is when the merging happens, and the merging is basically looking and saying, do we have windows that overlap? If we do, then you slice the one that's earlier and shrink it down. So this is basically what's happening. But that's only half of the story. We're talking about joining, so now let's get to that. Quick disclaimer, everything up to this point technically works in Beam. Everything after this is purely theoretical, not yet supported, opportunity for contributors to come and do something cool. So going back to our example data set, we had originally the rates table. That's the same thing that we had before. So now let's look also at orders. So these are orders saying, hey, I've got an order for 2 euros and I want to convert that to yen. So we want to join these together, and we want to do so in a way that uses the proper rate, the way that we've defined how rates work, for the event time of the given amount. And if we're to step through this, because again, you can see the processing times of sort of when records arrive and relative to that, we can step through and start to see some of the trickiness here. So if we start at say 12 o'clock, everything's undefined. If time advances to 12:05:07, we get our first record. It's actually the order. For whatever reason, we got an order in before we had any of the quotes, right? So we can't yet say how to convert this. We don't even have a rate yet. Next, finally, this rate comes in. And so we now know that maybe the rate is 114. Next up, we get a 119 rate. And then followed by that, we get another order. This one's for 5 euros. And at this point in time, it looks like the rate for that is 114, right? We're not looking at any watermarks here or anything, so we don't really know what the completeness is. But as it turns out, this 116 rate came in late as well. And so you can see if we had priced it at a conversion rate of 114, we would have gotten it wrong. But if we waited until we actually had the complete data and knew that we had the proper rate, then we would get the right price. And then lastly, there's one last value that comes in. But let's actually try to look at this in action now and see how watermarks help. So if we wanted to model this in SQL, using a syntax for the windowing that's kind of effectively what we do in Beam SQL. Imagine that we implemented Validity Windows as a SQL function there called Validity Window. It's a bit verbose, but there's kind of some main points here. There's the subquery that's creating the validity windows of conversion rates. It's basically doing the thing that pipeline I showed earlier is doing. And then we're joining that with the stream of valid rates. We're doing that by saying we want to make sure that the currencies match, so that they're both euros, and that the event time for the order, falls within the range of the window, right? It's greater than or equal to the start of the window, and it's less than the end of the window. And then once we've joined those together, we just do the simple, straightforward, multiply the amount by the rate to get the converted currency. And then again, using one of the extensions I talked about yesterday, if we added the submit after watermark, we'd guarantee that we would only materialize a result after a watermark had passed the end of the window it was in. And since we're using these validity windows as sort of the driving force for the join, it just works. And so if we look at this diagrammed out, it would look something like this, where you've got the orders in yellow coming in, and in white the currency rates. And the green here is showing you what the watermark looks like. And you notice that It's not until the watermark passes or reaches the individual orders that we can say, okay, we know the input is complete for everything up to this point in time for the order, and we'll materialize an output. And what's really important there is, like, if you look and see the order for 5, you know, if we sent out a result as soon as it arrived, it would have used the wrong currency conversion rate. But since we wait for the watermark to reach that point in time, then we actually use the right currency conversion rate. So that's really all there is to it. To summarize, you know, there's multiple approaches to gap filling time series data. As Reza talked about in the beginning, there's this imperative approach, or procedural, using state and timers. It's very flexible and straightforward. It's a bit more verbose. It's a bit more mechanical. But Beam fully supports all the necessary mechanisms to cover all the use cases, and you can kind of just do whatever you need to do to get the job done. And then I talked about this validity window approach, which is a more declarative or functional approach using windowing and triggers. In some ways, it's very elegant, and it's a very efficient way of representing kind of these spans or these gaps of area, or gaps of time that have values filled in them. It's a little less verbose, but it's a little harder to wrap your head around, I think. You know, this is kind of the general tension between, you know, procedural or functional approaches, right? Like, you can use C and just go in there and hack things out, and it's pretty straightforward and you know what you're doing, or you can use Haskell and it looks gorgeous and it's like 3 lines of code versus 200 lines of C, but it took you, 2 weeks to figure out how to do it. You know, and Beam lacks proper shrinking window support currently, so it remains a purely theoretical approach unless you're just wanting to construct the windows. But they're both sort of valid different approaches. And honestly, this holds true for most uses of these features. Like, pretty much anything you can do with windowing and triggers, you can also do with state and timers. And you get the same effect of, windowing and triggers is oftentimes more elegant and simple, but it can be a little harder to wrap your head around. And state and timers may be more verbose, but it's just, you just feel like you're just in there kind of walking through the steps. So something to keep in mind of next time you decide which approach makes the most sense. But that's all we have. Any questions?
All right, thank you so much for this session. I would like to open for questions. Please raise your hand if you have any.
There's one in the back.
There's one there.
So, first of all, great talk. You talked about 2 different applications for this, currency conversion and stock trading, or maybe stock modeling. Could you talk about some of the other applications? Because I think there's a ton of really interesting use cases out there.
So I'll talk through like a few of the ones that I have. So so the building of the stock values is relevant for any financial instrument, and there's a ton of use cases just in that area. So whether it's FX trading or if it's things that you are preparing for risk computations. So a lot of this stuff is the precursor to running risk grids and doing all the interesting stuff there. So there, it's actually preparing the information for those pipelines. On the IoT side, again, for example, if you had sensors in a retail store and the looping timers becomes useful. So the fact that no one's walking down the aisle is interesting information, not just when you have people walking down the aisle. So that in itself is an interesting use case. And those are the 2 core ones that I've worked with around these areas. Any more from you?
Any other questions?
Hi, thanks for the talk. My question is maybe a bit specific of your example of the trading, because you were talking about open and close, right?
Yeah.
And you said that there is, we can call it an invariant maybe, that the close of one time is the opening of the next.
Yeah, and it can be a religious discussion at some banks. Like some will say, no, that's not the right way to do it, and others will say, yes, you do, or some financial institutions. But the ones I've worked with, like the close to go into the open. Yeah.
Because I was wondering, in the case when you had a missing data point, you said, okay, you can take the close of the previous as the open, then you keep the close of the one that you're filling with the open.
Yeah, so you propagate, like the last price seen is still the valid price It's still the opening and close as you go forward until you see a new price.
And okay, but let's say the next point comes, and then it has an open, but that open will not necessarily be the close that you put in the time you filled.
Yeah, so that's a great point. So this is business choices, right? So what they want to do in that circumstance is up to the people that are building the candles and the rules that they follow. I suspect different ones will use different rules, but within the logic, is an easy way to solve the problem, right? So I've got a data point, I can make a choice, and we also can encapsulate so when I've been doing this, I keep the timestamp of the original value. So I know where it came from all the way through. So with that timestamp, you'll know that, okay, if the business rule is like, if this thing is from 5 minutes ago, then ignore it and use the current open. But whatever the business rule is, because you can take the timestamp value across with you, you can decide what to do at that point.
Okay, thanks.
Thank you. We have time for one last question. There we go.
So first of all, this is really cool stuff. Second of all, maybe a bit of an annoying question. So if I understand correctly, this is mostly theory right now. Is there plans to get this implemented or like?
So the validity windows?
Yeah.
So, no, there's no concrete plans. I mean, I think there are plans to implement retractions, which will be a key piece of it, so that will happen. And that might be enough to do shrinking window support, but it's certainly not the main motivation for that work.
And the SQL part as well, is that like?
So the SQL part, I mean, I think that will fall out naturally. We do want to be able to support, ignoring the validity windows aspect of it, just being able to do joins in SQL and the emit watermark. So that stuff's all planned.
Awesome.
Fantastic. Thank you, Reza and Tyler, so much for this session. We